In this video, I'm going to be talking about some probability tricks that we can do using an ordinary deck of playing cards. Now, I just want to make sure that everybody's on the same page here, because not everyone is familiar with playing cards, so I'm going to give you a quick rundown of how they work. A standard deck of playing cards has 52 cards. Half of the cards are red and half of the cards are black. Now, half of the red cards are hearts, labeled with a little heart, and the other half of the cards are diamonds, labeled with a diamond. Half of the black cards are spades, and they're indicated with this little symbol here, and the other half are clubs, indicated with that symbol. Each symbol is called a suit, so there are 4 suits in a standard deck of playing cards. Each suit has 13 cards, the numbers 2 through 10, and then a king, a queen, a jack, and an ace. So what we're going to do is we are going to pick one card at random from a deck of playing cards. Now, no matter what probability I want to find, there are always 52 cards in the sample space because there are 52 cards in a standard deck of playing cards. So we want to find the probability that the card we pick is red. Well, half of the cards are red. Half of 52 is 26. So the probability that we get a red card is 26 out of 52, or half, or 50%. The probability that we get a heart, that's one of the suits. There are 13 hearts in the deck, so the probability is 13 out of 52, or 1/4. The probability that I get a king, there are 4 kings in the deck, one for each suit. So the probability is 4 out of 52, or 1 out of 13. And the probability that I pick the king of hearts, there is only one of those, so the probability is 1 out of 52. Now, the nice thing about playing cards is that there are very, very nice patterns. The probability of getting a red card is 1 out of 2, or half, because half the cards are red. The probability of getting a black card is also half, because the other half of the cards are black. Likewise here, when we want to find the probability of any individual suit, there are 13 of each card. So the probability of getting diamonds is also 13 out of 52. The probability of getting spades is also 13 out of 52. And the probability of getting clubs is also 13 out of 52, or 1/4. The probability of getting any particular card, like king, queen, jack, or the numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, or the ace, there are 4 of each of these cards. So the probability is always 4 out of 52 for any named card like that. And lastly, I have the king of hearts. The king of hearts is one specific card. So the probability of finding any one specific card is always 1 out of 52. So we're going to be doing this same experiment, pick one card at random, for the entire video, basically. Let's figure out what's the probability that when we draw a card at random, we either get a king or a queen. It is not possible for one single card to be both a king and a queen, so these events are mutually exclusive, which means that we know that we can just add them together. So the probability that we get a king or a queen is the same thing as if we find the probability of getting a king plus the probability of getting a queen. So since the probability of getting a king is 4 out of 52, the probability of getting a queen is 4 out of 52, so the probability of getting one or the other is 8 out of 52. Here's another one. Let's find the probability that we get a face card. Now, face cards are cards that have pictures of people on them. So a face card is considered to be a king, a queen, or a jack. These 3 events are all mutually exclusive, so that means that we can just add their probabilities together. Probability of getting any card is 4 out of 52. So probability of a king is 4 out of 52, probability of a queen is 4 out of 52, probability of a jack is 4 out of 52. Add those up, we get 12 out of 52. So if you've noticed, I haven't reduced any of the fractions because I don't really care whether you reduce them or not. So let's look at finding the probability of getting a king or a heart. So I ask this question, is it possible to be both? Are there cards in the deck that are both kings and hearts? Well, if we list all the kings, we have the king of spades, the king of clubs, the king of diamonds, and the king of hearts. So yes, it is possible to get a card that is simultaneously a king and a heart. So these two events are not mutually exclusive, which means we cannot use the rule. So there are 4 kings and there are 13 hearts. But the probability of getting a king or a heart is not 17 out of 52. So let's look at the cards that we want and we'll see why. So let's list all of the cards that we could possibly want. First, I'll list all the kings. We have the king of diamonds, the king of spades, the king of clubs, and the king of hearts. And now I'm going to list all of the hearts. I've already listed the king of hearts, so that means I just need to list the other ones. So I have the queen of hearts, the jack of hearts, then the 10, 9, 8, 7, 6, 5, 4, 3, 2, and ace of hearts. So if you count all of these, there are 16 items that we want. So that means that the probability is 16 out of 52. If I would have just done the probability of getting a king plus the probability of getting a heart, I would have gotten 17 out of 52. But when I do that, I actually end up counting the king of hearts twice. I counted it as a king and I counted it as a heart. But there are not 2 king of hearts in the deck. There's only 1. So that's why we can't just straight up add them together. Now if I knew ahead of time that there is one card that is common to both sets, kings and hearts, and I knew that if I just added the probabilities together I would count the king of hearts twice, then I could be clever. I could do probability of king plus probability of heart, but then I could subtract away the probability that I draw the king of hearts because I have counted it twice. So that looks like this. We have 4 out of 52 for the king, plus 13 out of 52 for the hearts, minus 1 out of 52 for the king of hearts. And if you do the math here, you get 16 out of 52, which we know is the correct answer because we counted all of them. This is true in general. If we have 2 events, A and B, and they are non-mutually exclusive events, then we can figure out the probability of A or B by taking the probability of A plus the probability of B, and then we subtract the probability that we are both. So let's do another example here. Same experiment for the entire video. Draw 1 card at random from a standard deck of playing cards. We're going to find the probability that we get a diamond or a face card. Remember, kings, queens, and jacks are face cards. So the probability that we get a diamond is 13 out of 52. And the probability that we get a face card is 12 out of 52 because I found that probability earlier in this video. So the probability that I get a diamond face card is 3 out of 52 because the king, queen, and jack of diamonds are diamond face cards. So these are the cards that are both. So now I can work out the math here. The probability that I get a diamond or a face card is the probability that I get a diamond, 13 out of 52, plus the probability that I get a face card, 12 out of 52, minus the probability that I get a diamond face card, which is 3 out of 52. And after doing the math, we get 22 out of 52. You may have noticed that I never reduce my fractions, and that is because it is much, much easier to add and subtract fractions when they have common denominator. So everything has common denominator. That makes my life much easier.